Okay, let's get started. Thanks so much for joining us today. I'm Catherine Sbeglia, and I'm the technology editor at RCR Wireless News. Today, we'll be talking about the status of 5G globally when it comes to spectrum device adoption and trends. Keep in mind that we're recording this webinar and the slides and video will be made available on demand. There's also a companion report that explores these topics in more detail, which will be distributed in the next few days. We're joined by Adam Gould, Senior Vice President of Product Management at Inseego, Marco Contento, Vice President of Technologies at Telit, and Adam Smith, Director of Product Marketing at LitePoint. Please use the webinar portal to submit questions for our speakers throughout the conversation, and we'll get to as many of those as possible towards the end of our time. Despite the global setbacks presented by 2020, 5G adoption managed to not only beat the odds by accelerating during a particularly challenging year, but it is doing so faster than any previous mobile technology, as indicated by the latest Ericsson Mobility Report. Ericsson's findings released in November 2020 anticipated 220 million global 5G subscriptions by the end of 2020, followed by a 3.5 billion milestone by the end of 2026. When looked at by country as opposed to subscribers, Viavi's The State of 5G report indicated that 61 countries had 5G availability as of January 2021. And last year, 27 countries listed here added their first 5G networks. Perhaps unsurprisingly, China and the United States are well ahead of other countries when it comes to number of cities in which 5G is available, at 341 and 279 respectively. South Korea rounds out the top three with 85 5G connected cities. With that background out of the way, I'd like to welcome Marco to provide a further overview of the current state of 5G, as well as what's next in the technology's development.
Thank you, Catherine. Good morning. This is Marco Contento speaking from Telit. I will lead you to a quick, presentation about the situation of 5G globally in regard of the use cases and that 5G will enable. So let's. Okay, 5G is going to accelerate the digital transformation in different sectors. Of course, this will happen in different phases. We know that currently the 5G standard is based on release 15 that was released a couple of years ago, and essentially enable all the mobile broadband use cases, and therefore all the consumer products, including smartphone, tablet, and also connected PC, but also all the applications that somehow are grouped under the umbrella of fixed wireless access. So all the CPEs, router and gateways, and things like that that are required to support the broadband connectivity for several purposes. The next wave is going to be the release 16. This is a standard that has been closed last year, mid last year, and they will enable also additional capabilities, including the support of ultra reliable low latency communication that will enable additional use cases, and therefore there will be new opportunities for business, and in particular in the industry segment. And when we come to control automation, robots, and then things like that, where the cellular technology, in particular 5G, will somehow replace or support the specific use cases of the industry. The third wave would be based on release 17 that will come in release in 2022, middle of 2022. That is the date of the standardization. They will enable also additional capabilities, and in particular related to massive IoT, that will represent somehow the evolution of the current LPWA technology that we are all aware, like LTE-M and narrowband IoT, bringing some benefits with additional features, and will be based essentially on the new radio interface, 5G new radio. Next. So let's look at the numbers, and based on the market research report, Deloitte Technology is forecasting essentially for 5G IoT. So we are not talking here about consumer, annual growth that is in a range of 55%, moving from $695 million in 2020 up to $6.3 billion in 2025. If we look instead of the shipment module based on 5G technology, we're moving from 3 million units more or less next year up to 66 million forecasted for 2025. So it's a huge growth based on 5G technology and just for the IoT segment. We need also to highlight here the fact that the initial growth or the initial volumes and revenue will be generated by the technology available now, so essentially based on release 15, and gradually with the introduction of the new coming standard like release 16 and release 17, of course, they will contribute to the growth that we see in the coming year. To mention here that there will be also additional interesting use cases. In particular, I refer to the adoption of the cellular technology, in particular 5G, in the field of private networks. That is somehow an evolution of the use of LTE for private networks. But 5G is something peculiar because there are specific initiatives worldwide, and I refer to, for instance, the CBRS spectrum in the US or the allocation of a specific piece of spectrum in Germany that has been granted to the industry for private deployments. This, of course, will enable additional business, let's say, as we mentioned before. But of course, all these will not come for free because there are a lot of technical challenges that are needed to be somehow solved. In particular, when we look at release 16, there will be the need to solve the reliability, for instance, when we want to replace a industrial Ethernet connection with a 5G connection. And we mentioned before ULC, and this is exactly the feature that is required to support these specific use cases. And this is a huge gap compared to the legacy technology like 4G that is required to support it by 5G. So let's go to the next slide. Now, let's look at the deployment. We mentioned before that there are almost 60 countries that have commercially deployed 5G. So in total, we speak about 120 operators worldwide that have deployed commercially 5G, regardless the bands adopted. But in total, if we look at the total number of operators that somehow are investing in 5G, in trial, proof of concept, and so on, we are above 400 carriers globally and with 130 countries worldwide. Here we don't count, of course, all the companies that have been awarded in the spectrum of CBRS, for instance, we mentioned before. And in addition, if we look at the operators that are somehow investing in the deployment or testing actually of a standalone capability of 5G, the number of operators is 65 in totally. Surely, China is leading the deployments in 5G, standalone in particular, refer to that specific feature. Let's go next. One slide back, please. Thanks. This is instead reflect the situation for the millimeter wave deployments. So I refer to the spectrum that is above 24 gigahertz, and where we have in total 24 carriers in 15 countries that are actually deploying millimeter wave. In particular, there are 130 carriers worldwide in 43 countries that are testing or investing actually in the three major bands, so 257, 258, and 261. There are instead 32 carriers in 6 countries, and mainly in US, that are investing in the band 260. The licenses that have been allocated for millimeter wave are essentially more than 100, with a peak of license that is essentially allocated in the United States. Let's go to the next. So here is the situation for North America. North America has essentially deployed 5G in both millimeter wave spectrum and also in sub-6. Verizon and AT&T started first with the deployment of millimeter wave 5G, and then they are now also deploying in a sub-6 band. T-Mobile in particular started with the sub-6 band, in particular the 700 megahertz spectrum, where they have nationwide coverage. And then after the merge with the Sprint, they can also benefit, of course, of additional spectrum, in particular on 2.5 gigahertz. So now they are able to provide millimeter wave coverage in dense urban areas, and in mid-band spectrum, they provide coverage in metro areas, while in 600 megahertz band, the T71 bands, they can provide essentially the nationwide coverage. Next. This is essentially Europe, where the majority of the deployments, commercial deployments, have been in sub-6 bands with a different situation. Here, of course, we are just highlighting the major carrier like Vodafone, for instance, that have deployed 5G in Italy, UK, and Germany in a different band. They also launched 5G in Spain. Deutsche Telekom, that is targeting to cover half of the Germany population by end of last year. Actually, we should see now the situation after or during the COVID. And Orange, that is essentially targeting Spain and Romania. And Telefonica, that is deploying 5G in UK, Germany, and also Spain. Next. Here we are in Asia Pacific region with the three major carriers in China, so China Mobile, China Unicom, China Telecom. The peculiarity of these carriers is that they have deployed 5G in sub-6 bands, and in particular, they have deployed standalone capability. They are the first carriers that have deployed standalone. The other relevant carriers in Asia Pacific are located in Japan with NTT, Docomo, and SoftBank. They have launched commercially the service initially with sub-6, and they are now also moving to millimeter wave spectrum. And they're also looking to deploy standalone capability. Korea, SKT, KT, and LGU Plus, that they launch among the initial carriers the 5G services, starting with NSA, in particular targeting industrial use cases, and also looking at the standalone. Australia, they started to deploy 5G in sub-6, and they have in this quarter also the auction for the allocation of spectrum in millimeter wave. And relevant to mention here that in Japan, particularly the Fujitsu, was granted the first commercial private license 5G using millimeter wave spectrum combined with LTE, so NSA essentially, so using also LTE as an anchor band. Next. Okay, we are done.
Marco, thank you so much. Next, Adam Smith will offer further insight into global spectrum allocations with a particular focus on the importance of securing mid-band spectrum.
Okay, thanks, Kat. Thanks everybody for joining us. My name is Adam Smith from LitePoint, and I'm going to talk a little bit about kind of current events, what's going on with spectrums, deployments, and then in particular, give my point of view on what's going on with devices and test trends. So Kat, if we go to the next slide really quickly. For those of you that may not be familiar with LitePoint, we're a test and measurement company, and actually we are the wireless test arm of Teradyne. So my point of view as we go through this is we help companies characterize the snot out of their devices so that they get ready for production. So what we do is we help people get from new product introduction into high volume manufacturing. And so as we go through this and look at how this is impacted in 5G, what my point of view is going to be is how do we ensure that these 5G products work as they get either into enterprise or consumer hands. Next slide, please. So first of all, I grabbed this, I borrowed this data from IDC, and specifically it was their Q3 data from last year, because in their Q4 report, they actually dumped off 2019. But the key thing I want to point out here is that the adoption rate of 5G has been dramatic. I mean, this has been really, really fast. Kat showed on the Ericsson Mobility report that 5G adoption is accelerating faster than 4G adoption did. So, something in the range of 20 million smartphones in 2019, going to more than 200 million last year, and then expected to be somewhere in the neighborhood of 450 million plus smartphones. So going from basically zero to more than 30% of all smartphone shipping going to be 5G enabled just in 2 to 3 years here. It's pretty dramatic. That being said, if we go over to the right side of the screen here, it's a little bit of the devil's in the details when you look at how 5G is being deployed to the consumer, and from a marketing point of view. So I'm based in San Jose, so I just a couple days ago took this right off of Verizon's website. You can see their 5G coverage here, where the kind of the blood red color is their 5G coverage, but it includes 4G. And then if you look at the dark red there in a few streets, it's the available outdoors ultra wideband. So when we look at spectrum, 5G truly is going to be a combination of multiple different types of spectrum being utilized. And this is going to be somewhat network deployment dependent. But as we particularly look at the mobile use case, we're going to be looking at devices that have to be very, very versatile. And so if we go to the next slide, Kat. This is a slide that I've borrowed previously from Qualcomm as well. You can see that I put this up here as a little bit of an example of how diverse the spectrum deployment is for 5G. But typically when we talk about 5G spectrum, we're grouping things into, let's just say, less than 3 gigahertz being, or less than 2.5 gigahertz, maybe calling the low band. Then we have this 3 to 6 gigahertz spectrum range we could call the mid band, and then greater than 24 gigahertz in the millimeter wave space that we call the high band. And in North America, we've been very focused on making millimeter wave spectrum, so the high band spectrum auctioned and available to the carriers, and then refarming some of the low band spectrum. This year, we're starting to see, in fact, I'm going to talk about how dramatic it is, that the mid band is going to be the push for 2021. And 2022 here in North America. Whereas China, for example, Kat showed that US and China have been deploying the most number of cities. China took a concerted effort to focus on the mid-band to start. So they were opening up a lot of their 3 to 4.5 gigahertz spectrum. And they're just now starting to look at millimeter wave spectrum. So towards the latter half of this year, we'll see China allocating some of this millimeter wave spectrum for use. So just kind of two different ways of approaching the mobile problem, if you will. And then if you look over on the right here under the 64 to 71 gigahertz, it looks like every country's got work there. That's a little misleading in the 5G compendium because it's not necessarily the user equipment that's taking advantage of the spectrum. Even going back to 4G, the unlicensed 60 gigahertz spectrum was used for infrastructure, backhaul, last mile, tower-to-tower type communications. And we're seeing that moving forward in 5G as well. If we go to the next slide, Kat. This metaphor for the mid-band spectrum being the Goldilocks spectrum has been used. And the reason for that is because low band has very good coverage. I mean, it was like the ideal spectrum for 4G, but the bandwidth available is pretty limited. And then on the high band, this is really, for data-hungry applications, is really optimal for those because there's a lot of bandwidth available, but the physics of that spectrum make it difficult to deploy it doesn't go as far, it doesn't go inside buildings as easily. So then you come to this mid-band where it's got better coverage than the high band. So the physics allow it to travel further, go a little bit better through obstacles. And then you have more bandwidth than the low band. And I have a little bit of an artistic representation of scale of low band versus high band spectrum available over on the right there. Most carriers really only have access to 20 or 30 megahertz of spectrum at any given time. And even just going to mid-band of 100 megahertz of spectrum, that can enable carriers somewhere in the neighborhood of 5x more capacity. And then the high band, there's actually multi-gigahertz of spectrum available there, but any one carrier is going to only get access to something around a gigahertz, maybe a little less. And so coming back to the question, is the mid-band the Goldilocks spectrum? Kat's going to show us on the next slide here what's going on in mid-band. And I'll say this a little tongue-in-cheek, but the market has spoken. So we just closed off an auction of mid-band spectrum in the US here. And so this C-band spectrum auctioned off for roughly $81 billion, or roughly 300 million per megahertz, where you can see the top 3 carriers in the US spending that. I mean, this is, if you compare this to the millimeter wave spectrum auctions, which were roughly $1 billion for the 28 gigahertz. I mean, this is dramatic drunken sailor money being spent on mid-band spectrum. So clearly the market values mid-band, and that's going to be the focus for the next wave of deployments, at least here in the US. And we'll see additional spectrum auctions happening next year. Next slide, Kat. Now that being said, you know, when we talk about the millimeter wave spectrum, people talk about the indoor problem, but we also have this in the mid-band as well. You know, mid-band doesn't penetrate inside buildings terribly well. So one thing that we're looking at this year is that small cells and CPEs are going to play a crucial role as we build out our 5G networks here, and small cells in particular on the enterprise side. And then I might argue on the residential side, CPEs and gateways play, you know, play an important role in that rollout. And so what this is we're taking a wide area network and making these smaller area networks, whether it's a Wi-Fi on a CPE or whether it's a 5G signal on a small cell. And so if I direct you over to the right chart there, the key things to look at here are anything that's in orange. So we got the solid orange and then the dashed orange over here. That's the mid-band small cell forecast. So getting the mid-band spectrum indoors is going to be something that's going to be a focus, and it's going to be kind of on the back of the small cell for getting indoor deployment. And then likewise, if we look at the purple, so that's the dark purple and then the hashed purple there, that's the FR2 or the millimeter wave spectrum. And so you can see here clearly as we move forward in 5G, whether it's mid-band or whether it's millimeter wave, the small cell is going to play a big role in how this gets deployed to the end user, whether that's a mobile product or whether that's an industrial application. Next slide, please. And speaking of millimeter wave a little bit here, one thing I did want to point out, I found this particularly interesting as we're starting to see, particularly here in North America, as millimeter wave had proliferated last year. On both the infrastructure side and on the user equipment side, we're seeing the carriers really trying to optimize the spectrum that they've acquired here. So in the millimeter wave spectrum here, we see carriers deploying with these very wide channels. So the way we would refer to it in the 5G speak is they're using 8 by 100 carrier aggregation. So 8 100 megahertz carriers being aggregated and deployed to the device. And what this enables is very short transmission times. So it allows the carriers to use their spectrum very efficiently. And then likewise, the user equipment, whether it's a mobile product, it doesn't have to be on very long. So it helps with battery life. And so as we deploy more devices in this millimeter wave spectrum, we need to make sure that both the infrastructure and the end products are validated under these real world conditions. And so that's certainly been a trend we saw starting last year. And then Kat, if we go to the next slide, I'll wrap up with kind of a summary of the trends that we see going on in the industry and things to watch this year. So in the low band and mid band spectrum, what's called FR1 and 5G speak, clearly huge volumes. We've gone to hundreds of millions of devices. So one area that we're involved in is making sure that the 100 millionth line or device off the line works the same as the first one off the line. So there's a huge focus in quality in these FR1 devices as we scale the volume. And then also getting the selling prices down. So there's been a dramatic push on the ASPs. In particular, China is really made a push to make 5G smartphones available to a wide audience. And then as we saw on the spectrum slide, I mean, there's so many bands we are cramming into these teeny tiny little form factors, which are driving the antenna and the front end module technology in these things. And then what we also are seeing now is MIMO, so uplink MIMO in particular. So these FR1, the spectrum availability is better, or we're getting better, but it's still, we have to make relatively efficient use of the spectrum we have. So MIMO and FR1 actually allows for spatial reuse, and it also allows for the device to increase its data throughput in the spectrum that it has allocated, basically cramming more bits through the spectrum that's there. In FR2, one thing that we're watching is increasing millimeter wave attach rates. And in particular in the US here, one thing that was interesting last year that Apple introduced their all US SKUs have millimeter wave in them. And we expect this trend to continue as more and more mobile companies deploy 5G phones. 5G is going to have to take advantage of low, mid, and high band spectrum moving forward here. And then what comes with that, with scale, is really a focus on economics. So one thing we've been involved in is scaling these millimeter wave products to manufacturing with efficient manufacturing techniques. And so multiple device testing at the same time, faster ways of making measurements. And then as we look forward in what's going on in FR2 and an engineering development point of view, we have this new 47 gigahertz spectrum that was auctioned off last year, and we now have product development going on. So companies are looking to deploy in that network. And this is a particularly interesting spectrum because it's lower than the 60 gigahertz unlicensed spectrum, and it's higher than the quote unquote mainstream millimeter wave spectrum. So 47 gigahertz is kind of sitting in a little bit of a no man's land from a component availability point of view. So there's a lot of development going on right now on how to do integrated development around 47 gigahertz. And then likewise MIMO being deployed as well. And then closing off here around CPE and small cell development. So indoor 5G coverage is going to be a big focus this year. And then part of that as well is going to be deploying more and more 5G wireless broadband. So the carriers are using their 5G spectrum to kind of Trojan horse some wireless broadband services to compete with the cable companies. And then on the small cell side, we're seeing larger millimeter wave antennas being developed. And so the interesting thing from a test point of view is that on the mobile side, these small antenna arrays are actually pretty factory friendly with far field distances and roughly 10 centimeter type of range. As we get to some of these larger arrays, as we look at a small cell or maybe a millimeter wave repeater, the far field distances could get anywhere from up to 1 meter to 2 meters. And so that's an interesting little challenge we're going to have moving forward in the factory floor on how you efficiently produce these devices in scale and then also ensure the quality. And then what I expect to see continue this year is more spectrum proliferation. We're seeing carriers just spending a lot of money right now on spectrum, and they're going to want to make sure they monetize that investment. And I do expect low, mid, and high bands to be deployed globally eventually, right? US has made a focus on millimeter wave, and then will transfer to mid-band this year. China made an investment in mid-band, and now it's looking at millimeter wave. So at the end of the day, globally, we're going to have all of these bands deployed. And then, Marco mentioned this, but standalone is now something that's standalone deployments are trending out there as well. And so as we get beyond release 15, which is really mobile oriented, and get into release 16, we're going to need these standalone networks deployed. And I will cede my time at this point.
All right, thank you, Adam. Now, Adam Gould will offer Inseego's perspective on 5G deployment and device adoption.
Thanks, Kat. This is Adam Gould. I'm from Inseego. I'm just going to share a few thoughts here, and then we can quickly get you on to the Q&A section of the panel. So if you can go forward, please, Kat. Okay, so we all know that 2020 was a challenging year in many respects, and COVID in particular did actually, I think, slow down some of the 5G network deployments. We had issues like logistics, supply chain problems. We had concerns over financial situations. We had areas where with the lockdowns, sometimes operators couldn't even send installers out to put up cells. And so there was definitely a slowdown in the deployment. Now this sounds like it's contradictory to some of the thoughts my co-panelists shared, but it's really not, because while it slowed down to probably what it could have been, it was still really moving forward pretty aggressively. And people started to learn to figure out how to operate in this strange new world that we're in, and kept things going. And now that we're in 21 and we're starting to see some light at the end of the tunnel, we're really starting to see the interest level and the volume starting to ramp up and kind of start to hit that knee of the curve, of the growth curve from the products perspective. Next slide, please. So we're working on 5G here, but I always like to say that this is now my 6th generation of cellular that I've worked on, because I've worked on all 5 generations, and I worked on conventional wireless, before that. And I'll tell you that this is really to emphasize the point that Kat made at the very beginning of the the introduction, it's been phenomenal for me to see how quickly 5G has been rolling out as compared to some of the previous generations. You know, and I think it's really being driven by a whole new set of use cases that people are interested in with 5G. But just in terms of the new services that are being offered, the network deployments, the quick transition of phones and other products to support 5G, it's really been much amazingly faster than some of the previous generations. And by the way, I'm not even talking about just the cellular generations, but other technologies like Bluetooth and whatnot. These typically have taken a while, but the excitement and the demand for 5G has really been accelerated. The other thing that I'll mention is that going back to my previous point about 2020, while some of the network deployments did slow down, what it definitely did also was really drive the demand for connectivity of every type. 2020 made people realize, even more than they did in the past, that wireless connectivity is a crucial part of our everyday life, whether it's work or home or what have you, and is really also then driving us towards accelerating some of those new use cases. Next slide, please, Kat. Now, when we think about 5G, for me, 5G is not really about phones. And of course, there certainly are some great stats about 5G going into phones, and it's being adopted in those products, no question. But where the real value in 5G is for the new types of use cases, the new types of products that are really going to be out there, and driven a lot by the enterprise. And of course, on the bottom left here, we've got the obvious one, the kind of remote worker, and that's become a really important aspect of our lives, even going forward. There's people projecting that greater than 30% of the workforce, even post-pandemic, is still going to be remote. So having that ability to securely take your enterprises, your corporate network home with you, and make it such that your IT manager is confident in that has become really crucial. At the same time, then we have kind of more I'll call it pop-up type use cases. We see the construction on the top right, where you've got to have connectivity around a site, and it's kind of dynamic, or it's mobile on the bottom right. There's a lot of vehicular types of use cases that are coming. And overall, generally, we're starting to see enterprises really wanting to look at wireless as an option for their pure connectivity for the enterprise, whether it's a small business choosing that instead of wired, or it could be branch offices. There's just so many different, so much more confidence, I would say, in 5G as a wired alternative than there ever has been in the past. And a lot of that, some of that is the data speeds, certainly for 5G. Some of it is the security. Some of it is the private networks that are going to be offered. Some of it is just the spectral capacity that we have in 5G. Adam talked about the amount of mid-band spectrum and the amount of millimeter wave spectrum, and we have a lot of spectrum in 5G that we didn't have before, and that's really going to allow 5G to become that wired alternative in where fixed wireless access is one of those big use cases. Next slide, please. And finally, just a couple notes on Inseego, in case you don't know who we are. We've been around for about 25 years. We actually created the MiFi hotspot product category, and that was kind of our bread and butter for many years. But more recently, we've been expanding. Still, obviously, we just released our second generation mobile hotspot, but we've now moved into fixed wireless. And also our cloud solutions, and with a big focus on on enterprises as well. In fact, we are just getting ready to launch the rest of our 6-device product portfolio between fixed wireless, mobile hotspot, and industrial routers. So we're definitely looking forward to that growth in 5G and with a broad portfolio of products. And that's it for me.
All right, thank you, Adam. So now we will move on to our Q&A section. And the first question I'm actually going to pose to you, Marco, because it popped up during your presentation. And the question is, what are your thoughts as to why China has more deployments of 5G in the standalone configuration compared to other regions?
That is a good question. Well, there was they did this choice, and frankly speaking, I'm not aware of the drivers of this choice. I can only comment on some aspect, in particular the capability of the performance that the standalone can enable. Doing that, of course, they need to somehow duplicate the hardware of the network, so there is a much more investment that is required to be done. And in the other side, of course, they have to keep alive the 4G network in order to serve the legacy devices, because otherwise they cannot afford to switch off the legacy technology like 4G, 3G, or 2G, or whatever they have. It's a choice they have done. Frankly speaking, I'm not aware if there are any other, let's say, drivers that push the 3 carriers in China to deploy initially standalone instead of NSA. To say that NSA is somehow the natural path to follow, to have a somehow gradual investment from the carrier, because they can still leverage the 4G core network while they deploy the essentially the G0B, so the radio part of the 5G technology. And then, of course, the carrier are also looking ahead to enable 5G standalone, because there are some other capability that they can support, in particular network slicing where they can serve different segment, different use cases, while also supplying different quality of services.
Okay, great. Thank you. And I have a question here for you, Adam Smith, about the fiber optics requirements for low versus mid versus high band in 5G. Can you just talk a little bit about that?
Yeah, I saw the question come in through the chat here. I don't see a direct tie between the fiber optic requirements and the if you will, the physical layer. The fiber optic requirements effectively are really just, and I'm a little out of my area of expertise here because I'm the PHY layer guy, but the fiber optics is more around moving the digital data between the core network and the distributed units. Whereas the physical layer, whether it's low, mid band, or high band spectrum, that's purely just moving the digital bits, if you will, through the air. So I don't see a direct tie between those two.
Okay, great, makes sense. And
but just to add on to the question about the non-standalone in China, just an observation on my side. I mean, like Marco said, there's not necessarily a use case that's driving it, but it is. They've been doing this from a leadership point of view. Because what this allowed them to do as we move forward into Release 16, it makes Release 16 more like, if you will, a software upgrade than a huge investment to switch off the network. So they're just preparing for the future from a leadership point of view.
Okay, great. And actually just, following along with the talk of standalone versus non-standalone, I would like to get both of the Adams' perspective on the impact of 5G standalone versus non-standalone in terms of hardware components, and just how it will kind of impact devices moving forward. Adam Smith, if you want to start.
Sure. So maybe I'll start on the millimeter wave side, because at least if I look at a commercial millimeter wave network, if you will, a smartphone network, I actually don't see any value in doing a doing a standalone deployment, because it takes a lot of flexibility away from the deployment itself. So non-standalone is actually a really nice way to deploy millimeter wave, where you use the millimeter wave as a extension of the network, if you will, for the extremely data-hungry application. Then if we look at the FR1, mid and low band, the deployment of SA versus NSA is more of an architecture topology, if you will. It's not really a device so much. So if the chipset supports NSA and SA, which the 5G chipsets today do, then at least from a user equipment side point of view, there's no significant difference in the equipment.
Okay, great. Adam, Gould, did you have anything to add to?
Yeah.
Yeah, go ahead.
Yeah, I can add something there. Where I think it's going to come in actually is, again, different device types. So if you think about one of the things that standalone does for you is gives you the ability to use the network slicing aspects of 5G and giving you that private network. You know, I was on a panel recently with one of our partners, Swisscom, and they were talking about putting up a network slice for gaming in particular to provide good quality of service and that kind of thing. So as we start getting the use of SA to create those private networks for special purpose uses, it's the impact on the device actually is going to be on the variety of devices that are going to be wirelessly connected in those private networks. So to me, that's where the big interesting angle for SA is really going to be.
Okay, great. And Adam, if you also Adam Gould, sorry, if you also just want to address this question about the role of Wi-Fi in 5 years. I think this question popped up because of how much you talked about the importance of 5G in industrial manufacturing areas. So how do you see Wi-Fi and 5G kind of working together in the next few years?
Well, I still see them as being very complementary. I mean, we're, in a lot of our products, we're putting, 5G, Wi-Fi 6 in there, 6E, et cetera. The Wi-Fi world is still moving forward, and so is the 5G world. So these, we'll start to see, for instance, the local Wi-Fi networks that have a lot of different connected devices that need to be then, fast connected to the services that are controlling them. So there's still very complementary technologies as they always have been, really. The growth of Wi-Fi device types is going to accelerate, as will the growth of 5G device types. So it don't really, because it's going to all depend on. It's really the interesting thing about wireless is the number of usages are kind of limitless, and so there's really room for both technologies to play well.
Mm-hmm. Okay. And I have a question here that I think I might pose to all three of you to see if you all have something to say about it. But Marco, I'll start with you. What are your thoughts on the case in Korea where 5G users are planning to file legal action against mobile carriers due to poor 5G network quality? To what extent does this reflect difficulties of engineering, policy barriers, or high expectations from customers? Marco, did you have any thoughts on that?
Sorry, I was on mute. I was speaking with myself. I apologize. Yeah, I mean, we are at the beginning of the deployment, essentially. Even if we have said that some carriers have started to deploy already a couple of years ago, but I mean, the challenges and the investment that have been done and are going to be done are very high, and the technical challenges that we have in front of us are really big, and therefore, I mean, I can expect that at this point the poor coverage of 5G in some areas is something that can happen. So I'm not surprised about that. And if you look, for instance, we saw also a slide before with the coverage of 5G in a specific area. I mean, in San Jose. I mean, it's not that every place is covered 5G. So we need some time to see the deployment of 5G, in particular when we go outside the city center. So now, when we look at the millimeter wave in particular, we mentioned that, yes, there is a lot of bandwidth available. We can reach higher throughput, more capacity, everything is true. But of course, this comes with the need of placing small antennas almost everywhere. And of course, carrier cannot afford to do that in every angle of the cities, and therefore the coverage will be somehow spotty, with the pros and cons, of course. And And that is essentially the challenge. Millimeter wave is a technology that bring a lot of innovation and challenges, and therefore we have to accept the limitations.
Okay, great, thank you. And did either Adam Gould or Adam Smith want to add anything to that?
Yeah, I'm curious to see what this does, but I mean, if consumers are allowed to sue because they're getting bad quality, I mean, I should have been suing my carrier over the last 10 years because, well, maybe the last 5 years. I was getting kilobits per second in my Silicon Valley office on a 4G network, which is ridiculous, but it's because of the density of the network. So I don't know what claims that the Korean carriers are guaranteeing and what legal grounds there would be to sue against that. But I mean, we're clearly on the early deployment side of these new technologies, and user experience may vary in the beginning here.
Yeah, and this is Adam Gould. I would add, I just sort of playing on the last thing that Adam Smith said. You know, to me, this is just kind of the growing pains of a new wireless technology. You know, there's it takes a while sometimes for things to get dense enough where you really have that full coverage. You know, especially when 5G with the propagation issues, let's say, with both millimeter wave and even the 3.5 gigahertz type bands. You know, we're having to come up with creative new ways to deploy networks in order to get that coverage, whether it's through small cells or whether it's through targeted deployments, et cetera. So, like I said, to me, this is just the growing pains of the technology, and it'll fulfill its mission. There's no question in my mind.
Okay, great. And Adam Smith, going back to you, I have a question here about small cells. It was mentioned that small cells will be making a larger impact to address coverage of 5G deployments. Can you offer some thoughts on this statement, as small cells have been expected for many years now without real entry? What will make their deployment different this time around?
Yeah, so I don't think we're going to see a small cell in every residential neighborhood or every residence, but in 4G, we were mostly operating on low band spectrum, and in fact, governments were making a lot of effort to make even the 600 megahertz spectrum available, and which propagates wonderfully. So the need for a small cell in a 4G world was not very high because 600, 700 megahertz spectrum propagates very well. As if you remember the graphic I had from the small cell forum, where we see the growth in the small cells is more in the mid band and the high band spectrum, and that's because of the physical propagation. So in a 4G world, small cells originally were talked about in just getting network coverage in general, so being able to get voice coverage, if you will. But as we go into a 5G world here, this is going to be more in the data intensive use cases where we have the indoor problem. And so mid-band and millimeter wave spectrum indoor coverage, whether that's residential or enterprise, is going to be, getting that signal indoors is going to require something, whether that's a CPE turning it into Wi-Fi or whether that's a small cell taking the outside 5G signal to the indoors.
Kat, can I jump in there too?
Absolutely.
Yeah, so this is Adam Gould. Yeah, I definitely agree with everything Adam Smith just said. I think this is just another area where 5G is going to kind of turn the wireless industry on its head a little bit, because first of all, we've got the propagation issues with 5G, and so therefore you need to get full coverage in a broad geographic area, you need a much denser network, and therefore you need a lot more sites, and small cells will provide you that benefit of having kind of lower siting costs as well, which is a big part of an operator OpEx deployment, because they take up less space than a big base station, right? And so that propagation issue alone is going to drive a difference in 5G versus 4G. But the other thing is, and Adam Smith alluded to that as well. The use cases in 5G are so different from 4G. You really need that high data rate coverage that for a lot of these use cases. That's when you start going beyond a phone and beyond I'm just going to look at whatever my Facebook video is playing, something that's really more mission critical. That's when you start going to really see kind of that densification need for 5G start to rise up.
Okay, great. And Marco, I have a question here for you. Aren't enterprise 5G applications more likely to be the domain of neutral hosts and ESPs rather than MNOs? I guess, what is your perspective on who will be, the big players in enterprise 5G?
The neutral host is something that will become relevant for the deployment of 5G, in particular when we essentially come to the need of sharing essentially the investment and the effort to deploy and support 5G in specific areas, and therefore neutral host is something that is relevant for these purposes, sharing essentially the hardware infrastructure by providing meanwhile the covered by different carriers. So in particular, when we look at millimeter wave, this will be even more important when we want to cover a small site, and the investment can be shared across the different carriers.
Okay, great. And so I have a question here about how important is the open movement within 5G infrastructure like Open RAN? How will this impact the deployments and support of 5G? Marco, why don't you start, actually? I'll ask everyone for their input in this. I can repeat the question if you'd like.
Well, Open RAN is essentially the Open RAN architecture is something that will enable additional players to enter into this new game. So the possibility to supply equipments that will be used in the 5G deployment, particularly on the network side, because we're talking of this side of the architecture, and apparently this will allow the compatibility across all these devices, and therefore there will be more competition across all the essentially the infra vendors. So this will open the door not only to let's say the supplier that we are used to hear, like Ericsson, Nokia, Samsung, and so on, but also to other players that will be able to supply equipment that will be somehow compatible. And this will probably help in essentially, let's say, keep under control the investments that will be done by the network operators, or optimize the cost and so on for the deployment of 5G network.
Okay, great. And Adam Smith, Adam Gould, did either of you want to add anything about Open RAN?
Yeah, I can add. This is Adam Gould.
Mm-hmm.
Yeah, we do a lot of work with the Open RAN vendors ourselves, actually. And I'll tie this in a little bit with the previous question on the MNOs versus ESPs. I'll sound a little bit like a broken record here with talking about the wide variety of 5G use cases, but along with that is there's clearly going to be a big growth in private networks, and certainly the MNOs are going to be very active on kind of the enterprise side of 5G, and the MNOs have historically kind of been the domain of the big infra guys, Nokia and Ericsson, et cetera. And then as we start to get some of these other more private network deployments, and some of the new guys that are coming up, guys like Dish, for instance, there's going to be these Open RAN players are really going to be starting to gain some traction, and it's just going to be a wider variety of players in the industry, which is great for the industry. That competition is going to be really good. So those private networks, I think, are really going to be a keen opportunity for the Open RAN vendors.
Adam Smith, did you want to add anything?
I think Adam Gould said most everything I could. The Open RAN really is a way of democratizing the infrastructure equipment, and so I think it's going to be. Having more options and more competition is never a bad thing.
Okay, great. And Adam Smith, do you think that carrier aggregation of LBFDD with MBTD TDD will be the traditional configuration for 5G SA deployments?
So low band and mid band carrier aggregation. I wouldn't say it's the traditional configuration, but it's a possible configuration, certainly.
Okay, great. So let me see what else I have here. Oh, I have a question here about the implementation of non-terrestrial networks and how that will impact 5G, which I know is something I think I've spoken to you, Adam Smith, about. Is there anything, do you want to answer this question maybe?
Yeah, I mean, the non-terrestrial networks, I think this is a huge boon to those in rural areas. I mean, the big carriers are going to certainly be focusing their infrastructure build out in the population density areas. So for non-terrestrial deployments, I think the people that don't have access to a high-speed millimeter wave fiber to the, or excuse me, millimeter wave or fiber to the home, I think it's great for them, and it, you know, certainly is a good complement to 5G.
Okay, great. And Marco, the next question is for you. What is the difference between low power and high power millimeter wave device operation, and when should we use one or the other?
The difference between the two is essentially in the power level, but it's also related to the use cases. When we refer to low power, we essentially refer to what 3GPP defines as a power class 3. That is a power level that is used for the mobile handset, essentially. And where you have a millimeter wave antenna installed on the border of the handset that provide coverage in millimeter wave. Usually those antennas are multiple antennas, and only one usually is connected to the base station. So the spherical coverage in that case is essential. So usually in the design phase, the customer has to take in consideration how the shape of the device that I mentioned, and a handset, but can be also a different device like a Wi-Fi, for instance, in order to place the antennas properly. In the case of high power antenna, instead, we refer to a different power level, which is defined in power class 1, which is about 40 dBm minimum peak ERP. In that case, the use case that has been defined by 3GPP is related to fixed wireless access. And in that case, the antennas are essentially placed on the same plane, and because the aim is essentially to direct the antenna against the base station, and therefore the spherical coverage can be somehow narrow, because we want to achieve essentially the maximum power in that specific direction. Usually those antennas are, of course, directive. Sorry, they are, let's say, somehow, yes, they're directive, but I mean, the beam can be steered, and then also in order to direct in the proper direction. And this is true for both the low power and high power.
Okay, excellent. And I think we have time for one more question, which I will pose to Adam Gould. Do you see 5G millimeter wave indoor usage more as a substitute or as a complement for FTTH?
Well, I think it's a little bit of both. Actually, we've got, on the one hand, we've got operators that have, and we're talking to our operator customers directly on this topic. As a matter of fact, we've got operators that today already have some fiber, but they don't have it everywhere, and so they want to be able to have kind of extend their fiber-like coverage area with 5G. Likewise, we've got in other cases where you really have to have 100% uptime of your connection, and making sure if your fiber were to go down for even a minute, you could have the 5G to fall back on. So that kind of use case is happening. But then we've got other operators that are using 5G essentially to compete with the wired guys, with the guys with fiber. So it kind of depends on a little bit on your legacy strategy around this. Have you been going down the fiber path or not? Fiber is expensive to deploy, can't be deployed in all areas, and that's where 5G can come in to complement that. Or it's competition where, you know, 5G is my primary option. I don't have a fiber strategy. So it's really kind of a bit of both, actually, both competitive and complementary.
Okay, excellent. So thank you all for tuning in, and a special thank you to our 3 speakers. Make sure you keep an eye out for the companion report, and have a great rest of your day.